Hey, if you don't have a printed copy of these notes in front of you for this lesson, pause this video right now. If you can get yourself a printed copy, get a printed copy. Go, pause the video now, get yourself a copy. All right, I'm going to assume that now if you can have a printed copy of these notes in front of you, if you do, now I want you to pause the video again and I want you to try to solve all 5 problems on this page before watching any of the rest of this video. Go, pause the video now and try to solve all 5 of these problems. Okay, now I'm going to assume if you've tried to solve these problems, now I'm going to solve them. F is 2/3 of the way from W to E. All right, so there's more than one good way to do this, but one way that I like is to find out how far is it from W to E in a horizontal direction, how far is it in a vertical direction, and then take 2/3 of those distances and travel that much. Now, what a lot of my students do, I see, is they draw lines here and they count the lines. Oh my gosh. Let's use some arithmetic, shall we? Arithmetic makes life a lot easier, saves you a lot of counting. From 7 to 25, that's an x coordinate of 7 to an x coordinate of 25. In the x direction, from 25 to 7, it is 18 steps, right? A little subtraction saves you a whole lot of counting. Now, we want to go 2/3 of the way of that 18 steps. So 2/3 of 18, the word of in English often translates to multiplication in mathematics. 2/3 of 18 is 12. So we want to go 12 steps in the x direction from the 17 towards the E, because the question is saying we want to go from the W to the E. If it said from the E to the W, then we would take 12 steps backwards from the 25 towards the 7. Okay, but we're going 12 steps from the 7. So starting at the 7, we add 12 to that, we get 19. There's the x coordinate of the point we're looking for. Sorry, that ran off the screen a little bit. Okay, 19, because we started at 7 and we went 2/3 of the 18 steps that it would take us to go from W all the way to E. Now, what about in the y direction? Same thing. How far is it from 2 to 14? Again, a little subtraction saves us an awful lot of time. 14 minus 2 is 12. Well, we don't want to go 12 steps vertically. We only want to go, as the problem says, 2/3 of 12 steps. And 2/3 of 12 is 8. So starting from the 2, if we go 8 steps vertically towards the 14, then we would get to 10. There is the y coordinate of the point we want. Okay. Now, we have not written the answer to the question yet. You got to answer the question that I'm asking. What are the coordinates of F? Okay, final answer, 19, 10. Okay. Now, here's another acceptable way to do this problem because it has been graphed. Okay, and it's not so hard to do it this way either, and it involves a certain amount of counting, okay, which is not bad when the counting is not so, you don't have to do so much counting. Right? You can see that this line here goes up 3, or excuse me, over 3 and up 2, 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 and then finally over 3 and up 2. Well, there's 1, 2, 3, 4, 5, 6 of these steps to get from W to E. Once again, that's one. You don't count that spot there, right? 1 step, 2 steps, 3, 4, 5, 6 steps of that much each time to get from W to the top. If we want to go 2/3 of 6 steps, that would be 4 steps. And so from the W, we would count 1, 2, 3, 4. There's the point we're looking for. We can read the coordinates off of the grid. Down here, that's a 19. And over here, that's a 10. And so the answer would be 1910. And some of you might think, come on, Artillo, that seems to be a much faster, easier way to get to that point than all of this arithmetic and calculations. You said arithmetic was going to save you time. It doesn't seem like it saved us a lot of time there. Well, let me tell you, if the coordinates of the points were, let's say, 5, 9 and 328, 577, you would not want to be, counting off every little step of the way. You'd want to do the arithmetic for sure. That would be a way faster and a much more reliable way of getting the exact correct answer than doing this. Now, when I quiz you on this kind of stuff, I may give you a segment on a grid where the counting is not so time intensive, and you can do the counting if you want, but this would be a good method to have in your pocket also, okay? If H is the midpoint of WE, the midpoint, now what does midpoint mean, okay? A midpoint, you have to understand this. Midpoint in mathematics has a precise definition. It is exactly halfway between two other points. Exactly halfway. Same distance to one point as it is to the other. Midpoint does not mean somewhere vaguely in the middle. Okay, somewhere in between. This is not a midpoint of W and E. It's not exactly halfway in between. That's not a midpoint. This right here, you can see visually, that's the same distance from W as it is from E. You can count. It's 1, 2, 3 steps of equal length towards W and 1, 2, 3 steps of the same length towards E. That's the point that's exactly in the middle. And having marked off all of these steps, we don't have to do much work to identify the coordinates of that point, which are 16, 8. Okay. But again, if we choose this arithmetic approach, from 7 to 25 in the x direction, 25 minus 7 is 18. Oh, why did I waste my time doing that? I already figured out up there how long it was from one x coordinate to the x coordinate of the other endpoint, 18. But this time, if we're looking for the midpoint, we only want to go halfway, half as much of that 18. 18 times a half is 9. We want to go 9 steps to the right of 7. 7 plus 9 is 16. And in the y direction, it was 12 units from the 2 to the 14. So once again, there's the x work. Here's the y work. 12 units times 1/2 is 6 units. So we want to go 6 units from the 2. So starting from the 2, we go 6 units up, and that takes us to 8. And then once again, our final answer is the ordered pair 16, 8. Okay. Now there is a third way of finding the midpoint. And this is a method that we cannot apply to points that are other fractions of the way, like 1/3, 2/3, 4/5, 3/8, things like that. When you're looking for a midpoint, there is another way to express the relationship between the coordinates of the midpoint and the coordinates of the endpoints. And I'm going to write this down at the bottom of the page here, and we're going to take advantage of this. And actually, it's in this question right here, okay? If we're just calling the coordinates of point A some random x and y values, x1 and y1, and point B, again, some other random x and y values, x2 and y2, the coordinates of the midpoint can be found by averaging the x coordinates. You know what averaging numbers means. It means add up all the numbers and divide by how many numbers there are. Well, there's only 2 numbers, so we add them up and divide by 2. That would give you the x coordinate of the midpoint. And to find the y coordinate, do the same. Average the y coordinates by, of course, adding them up and dividing by 2. Okay? Now, I'm going to erase this midpoint here, this abbreviation for the word midpoint, and I'm going to replace it with another ordered pair. And I'm going to call that ordered pair X, and then a subscript M for midpoint, the X coordinate at the midpoint between points 1 and 2, and comma, Y coordinate at the midpoint between points 1 and 2. Okay. Now this is a formula then for the coordinates of a midpoint between two other points that is very worthwhile you knowing. Okay. This right here is in fact the answer to this question. Okay. And this formula can be very, very useful in answering some other questions. In fact, it could have been useful in answering question number 2. Right? What are the coordinates of the midpoint of WE? Well, average the X coordinates. So here's a third way of doing number 2, and it's the way that I think is the quickest, easiest way of doing number 2. Assuming you hadn't already, marked these equally spaced dots along the line. Suppose you hadn't done problem number 1 already, and you hadn't done all that counting and marking. All we'd have to do is average the X coordinates, 25 plus 7 divided by 2, and then average the Y coordinates, 2 plus 14 divided by 2. You could probably do that in your head. You probably wouldn't even have to write that down. And some of you might get it right in your head and get it wrong if you reach for a calculator, because I see some students, not many, but I see some who will put this into their graphing calculator like this, 25 plus 7 divided by 2. And if you do that, the answer comes out to 28.5, right? Well, the average of 25 and 7 can't possibly be 28.5. So why are you getting that answer when you put this in the calculator? Because the calculator will do this arithmetic in the order of operations that it should, which means it's dividing the 7 by 2 first and getting 3.5, and then adding that to the 25 to get 28.5. I mean, you get an answer like that, you should know. Red flag should go off in your head. That answer does not make any sense. The average of two numbers should be some number in between them, not some number greater than both of them or less than both of them. Okay. So once again, that leads to the answer when we simplify all of this, 16, 8. Okay. So for number 3, now this is I hope you were careful of this. S is the midpoint of NG. This is saying that S up here is the midpoint between N and some other point G that is not plotted for us on the grid. Okay. This question, number 3, is not asking you to find the midpoint of NS. See, it doesn't say NS. It's not looking for the midpoint of this segment. It's saying S is the midpoint of some segment that we can't completely see. Okay. But if S is the midpoint, it must be the same distance from N as it is from that other point G. And once again, we can do some counting to find G, or we could do some arithmetic to find G, or because this is a midpoint problem, we could use this formula. Okay. Now I'm going to do this 2 ways. I'm going to do arithmetic and I'm going to use the formula. If we do some arithmetic, we find that from S to N, in the X direction, 8 minus 1 is 7 steps. Okay. In the X direction, let me show my work here. 8 minus 1 is 7 steps. Therefore, point G must be 7 steps this way in the X direction. Okay. Well, that's past 8. We're getting larger than 8 as we move in this direction. Right? So starting from the 8, if we go 7 steps beyond that in the X direction, we get to a coordinate of 15. In the Y direction, let's see, 20 minus 17 is 3 steps. Okay. And then again, we're going past the S. Are we going up or are we going down? In the vertical direction, up or down as we travel this way? We're going down, aren't we? So we would not add these 3 steps to the 17. We would subtract them from the 17. Okay. And there's going to be the Y coordinate, 15, 14. that's where G ends up. And if we plot 15 comma 14 very carefully, it should look good. There's 15, 14. Yeah, that looks like S would be the midpoint of those two. Okay, so pay careful attention when you're looking for another endpoint as to whether the endpoint's coordinates should be, increasing past the midpoint or decreasing. In this case, the X value is getting larger, but the Y value is getting smaller. Okay. Just pay attention to the direction that things are going. That's all. Sometimes students ask me, how do you know if you're supposed to add or subtract? And I say, well, look at the picture. See which direction things are going. Okay. Now, here is an alternate way of doing problem number 3. You're probably not going to like this way so much. It may seem more complicated and difficult to you. But again, if the numbers are much larger and the counting would be a lot, but the arithmetic still wouldn't be, no matter how large the numbers get, the arithmetic work really doesn't change. It doesn't get any more or less difficult. So I suppose you could use that method and you'd be fine anytime. But here is an alternate way you could do it. I'll do this real quickly because probably not many of you are going to be a fan of this. You could use this formula, okay, and plug the coordinates from the information that we have into the proper places in the formula. Now, the 1 and the 20 are X and Y values of one of the endpoints. And here's coordinates of endpoints right here. Okay, so we have one X coordinate, it's a 1. We don't have the other one. We don't have the X coordinate of the other endpoint. Okay, so I got to leave that as a variable. And then we have the coordinate of one endpoint. We have the Y coordinate. We don't have the other one. What we do have are the coordinates of the midpoint. So I can plug those in. 8, 17. 8, 17 were the coordinates of S, which we were told is the midpoint. Now, I'm going to separate this into 2 separate equations. Take the X coordinate of midpoint, equate that to this expression right here. 8 is equal to 1 plus X over 2. Right? I changed that X sub 2 to an X because at this point, it doesn't really matter what I call this thing. An X is just a little bit simpler to write. Okay. How do you solve this equation? You could do this. This is very easy. Multiply both sides by 2 to cancel out the 2. We got 16 is equal to 1 plus X. Subtract 1 from both sides, and you get X is equal to 15. And I could do the same thing with the Y business also. Make that 17 equal to 20 plus Y over 2. Solving that equation is easy. Multiply both sides by 2. You get 34 is equal to 20 plus Y. Subtract 20 from both sides. You get Y is equal to 14. Ha! We did it. Same exact answer as we got earlier, 15, 14. Okay. So back to number 4. Here's an example of a problem where you do not want to try to graph this. You do not want to try to count your way from 36 to 80 or from 100 to 120. You want to do some arithmetic, don't you? Okay. And you can do the arithmetic one of 2 ways. You can find the distance from 36 to 80 by doing subtraction, like we did for numbers 1 and 2 the first time we did them. Find out how far is it from 36 to 80. 80 minus 36 is 44 units. It's 44 steps from 36 to 80, but we only want to go half of that. Half of 44 is 22. So we would add 22 to the 36 and come up with 58. Same thing with 100 and 120. Although a lot of you, I'm sure, could look at 100 and 120 and recognize immediately that the number that is exactly halfway between 100 and 120 is 110. Okay, so we can do the subtraction method, or we could use the averaging method. 36 plus 80 divided by 2, that's 116 divided by 2 is 58. And then 100 plus 120 over 2, That's 220 divided by 2 is 110. Final answer, 58, 110. I would say that is the quickest, easiest approach by using the midpoint formula. Okay. And as a bonus here, I'm going to give you two more problems on the back of here. And so if you've got a printed copy if you don't have a printed copy of these notes, realize here I'm putting two extra problems in the video that you will not have on your paper and that are not going to show up in the notes that will be posted for you. These are just kind of bonus problems here. Let's suppose I'm giving you a point at 15, 90, and M is the midpoint, and it is at, let's call it 77, 16. Okay, and then B is the other endpoint. Find B. Okay. I sometimes like to draw a sketch for myself, just a rough sketch. It does not have to be accurate in terms of the numbers or the length, but what can be helpful to me in the sketch, 15, 90, see, that's it. That's as accurate as you have to be. 15 is a little bit to the right, 90 is way up compared to 15. There's point A. Where would 77, 16 be compared to this point? Well, 77 is way past 15. 16 is only a little bit up, right? So there's point M at 77, 16. So from this picture, I can tell, even though it's not, super accurate to scale, I can tell that point B is going to be down and to the right. In fact, its y coordinate looks to me like it's very likely to be a negative number. So these are good clues to have, good visual clues to have before starting the problem. Okay. Now, again, you can find out how far is it from M to A, and then do the arithmetic to take you the same distance in that direction. I'm going to use the midpoint formula. Okay. These B coordinates, I don't know what they are. I'm going to call them X and Y. I could call them X2 and Y2, but it's just a little simpler to call them X and Y. Okay. And then what I know is that the average of these endpoint X's must equal 77. 15 plus X divided by 2. When you average those X coordinates, you must get 77. And this equation is so easy to solve. Right? Multiply both sides by 2. 15 plus X is equal to, pick up your calculator if you need to, 154. Subtract 15 from both sides, and X is equal to 139. How fast was that? I mean, I know I'm working fast, but even for you, this would go fairly quickly. Okay? If you realize that the formula can help you. Okay? Formulas, relationships are wonderful things. Okay? Same with the Y's. The 90 and the Y have to average to be 16 because the average of the endpoints gives you the midpoint. So 90 plus Y over 2 has got to be equal to 16. Multiply both sides by 2 and you get 90 plus Y is equal to 32. Subtract 90 from both sides. Oh, here comes that negative number I was anticipating. Y is equal to negative 58. And that makes sense based on the picture that I drew for myself, doesn't it? Do not freak out over negative number answers, people. They are valid, okay, sometimes. So the final answer then, 139 comma negative 58 as an ordered pair. Okay. We'll go back to the front side. This formula, very, very useful. You should know it. It might be even more useful for you to write it really as two separate formulas, okay, that the X midpoint is the average of the two X endpoints, and that the Y midpoint is the average, Y1 plus Y2 over 2 is the average of the Y endpoints, okay? And that should do it. Good luck on the homework.